All right, in this video, we're going to continue with the toilet insulation, topic 7. So in your notes, we're looking at objective 3.7.3. All right, so we're concerned here with identifying, describe, and give the function of the components of a wastewater drain system for a toilet. Okay, so the wastewater drain system is separate from the supply side. So we're not concerned with bringing water into the house now. We want to be able to get the used water, the wastewater, away from the home. Supply side had to be concerned with pressure reduction and water hammer. So again, thinking about how you would gain water to the home, you may need reduced pressure. You had to be careful of particular types of valves and water hammer. None of those are concerns here. We're dealing with a low pressure system now. The drainage system is concerned with the buildup of sewer gases in the home and how to prevent them from entering the home. Aside from being unpleasant, if there's sufficient methane gas built up, and that comes from sewer gas, it can be explosive. Gas are vented through the roof with carefully placed vent pipes, and gas are prevented from entering the home through the use of traps with standing water in them, and we'll demonstrate those. So some points to take note here. Drainage of wastewater depends on gravity flow, so all waste plates have a slope towards the exterior sewer system. Typical drainage and how that will work. If you had a pipe, say if it's running a foot, so this is your drainage pipe, water is draining away within this pipe here. For every foot that the pipe travels horizontally, so across, it should drop down 1/8 of an inch. And if I can, okay. Anyway, so it should drop 1/8 of an inch. So as the pipe travels 1 foot, it drops 1/8 of an inch. If it traveled 8 feet, it would drop 1 inch. So it's not a huge slope, and you just need enough of a slope so that gravity just pulls the water and any waste material away. Every waste system has a built with sewer gases, so 2 controls are used. You vent through the roof of the building at each point of waste origin, for example, a sink, toilet, or washer. That doesn't mean that you have multiple holes or lines going to the roof. You vent at those locations, and we'll show you now what that would look like. So we have just a simple diagram here. We just start at the bottom and work our way up. So here at the bottom, you would have wastewater leaving the home here, going through. A clean out, that's a screw-on cap. So if you find that in your home, if you have a blockage, perhaps you have some waste material, toilet paper, something that causes a blockage, you can actually run a device in there called a snake and break up the blockage. So that's the purpose of the clean out. So we look at your sink here, and we'll look only at the bottom half here right now of the piping system. So you let water in your sink, water comes up. This is called a trap, and the water will leave and come right through. Okay, so we're going to ignore the top part of the diagram there. If we look up, you have similar issues going on with the sinks upstairs and the toilet on the second floor. So again, you turn tap on, water would come and leave, flush down here, flush the toilet, go down through. So this is through your drain stack here. Now, if you had only that system and didn't have the pipes, if you didn't have these pipes here continuing up, what would happen is that the system would become airlocked. So as the water is trying to flow down through, it's going to push air with it and out the way, and the system won't drain well, if it drains at all. I doubt it would even drain, because air needs to enter into the system. So as air is getting pushed along with the water and down, fresh air has to come in and replace it. So that's the purpose of these pipes here extending up. This is your venting system. So everywhere where you're having water leave the home, say at a sink right here, you're going to have a vent pipe. And same here with your toilet and at your sink. So these are not all making separate holes into the roof. They're connecting together and going out through. And if you notice here, it also says air supply. So sewer gases are also able to leave, but air is also able to enter and come in. Think about it this way. I'm sure each of you go home, you have a can of milk in your fridge. If you put just one hole inside the can and try to pour the milk out, it won't work. So you just put one hole in the can, try to pour it, you're not getting anything come out. You need two. You need air coming in to the can so that you can get liquid leaving. This system, same principle. You need air coming into the system so liquid can drain out. These traps we spoke about here, or I mentioned, the way they're designed is there's always a little bit of water left in them. So if you turn the sink on, within this little belly here, the bottom part of the trap, it doesn't fully drain because it rises up and continues on. So there's always a little bit of water stays here, and that prevents sewer gases from passing through. So sewer gases are going to travel up through the system, and they won't be able to get into the house because the water acts as a block to it. The toilet itself, you might not notice a trap here, but the design of the toilet has a built-in trap. So traps are at each water appliance and hold standing water to prevent gases back into the building. So we just have a typical sink. You have a drain or tailpiece. And if you look at your trap under your own kitchen sink, it's going to hold water. If you look down in there, you should actually see water. I don't know if you'll see goldfish there, but hey, who knows? And some of the traps are actually going to have a little plug here that you can unscrew. So if you dropped a piece of jewelry or an item down there, it would get caught here and you could pick it up. Okay, so you turn the water on, it drains that through, but there'll never be enough force to drive all the water out. There's always going to be a little bit left behind. And that connects, so as water's flowing, it then comes out to your drain system, so water would go down this way. Air is also coming in this way. So you get a two-way movement of air. So let's just take a pause here for a second and think about what's going on. Water's going to leave and come down. Sewer gases are going to build up within the septic system itself. They're going to come up and go out through the top of the roof. They're also going to try to come this way, but they won't be able to get into the house because this water trap will prevent it. And you also will have air coming in because as the water drains away, again, you don't want the system becoming airlocked. So it resupplies air back into the pipes. And toilets, regardless of wastewater, have built-in traps. So large wastewater pipe, no trap on the pipe. So you usually get a 3-inch pipe there. It's a large amount of water that goes through. So just with the design of the toilet, you got your bowl full of water here, and the water will go up over and down. So you never completely drain a toilet. The toilet always holds water in, and that prevents any sewer gases from coming back up and into the home. In a lot of cases, if you've ever had to take the toilet off the floor of your house, maybe you've had some issue with it, you'll see someone will plug the hole. So there'll be a flange here that the toilet sits on and is bolted to. And usually someone would take maybe a plastic bag or a rag and just plug that to prevent the gases from coming back in through. Okay, we'll now pick up with the next objective. So 3.7.4. Okay, in this one, we'll identify the different types of fixtures, tubing, pipes, connectors, and fittings used in toilet installation. All right, within this section now, we'll look at different types of fixtures, tubing, pipes, connectors, and fittings used in toilet installation. So this outcome enables students to get a glimpse of a variety of plumbing options that are available for supply and waste systems. So drain system was traditionally constructed from cast iron. Most homes now have ABS piping, so a type of plastic piping. But before they would have been iron pipes, and you still find them in older homes and buildings. So this ABS piping, you've seen that in the shop. And if you've seen, looked underneath your own kitchen sink, you've seen the ABS pipe. Now, likewise, copper is the traditional choice for hot and cold water supply. Metal piping. Many houses are now being plumbed with PEX, so you don't hear of new homes being plumbed with copper piping. It's all PEX, and older homes are getting their copper pipe replaced with PEX. So PEX is just an acronym, PEX, for cross-linked high-density polyethylene. We're going to call it PEX. So copper is joined using adhesion soldering. So what happens with soldering is that you put a torch on the pipe, heat the pipe up, and you put a metal solder next to that. And the solder actually gets pulled in through the fittings here where the pipes join and gives a waterproof connection. Again, useful skill, no, but one that is not used a lot anymore. So examples here of PEX. So this would be for shower. So they've got a color here for hot, another color for cold. And you see above that, they've got the arresters here. So we spoke with this. Here are the arresters for water hammer. So if you shut the water supply off, so if you think if you're in a shower, if you got a main valve here, you turn left to right to get a mix of hot and cold. And if you shut it off quickly, the water's flowing up through the hot water fairly fast, comes here, goes up to your shower nozzle. But if you turn it off fast, the water goes forward and into this arrestor. So this is all the PEX, and it's joined with copper rings. So you see example of that here. And it's called crimp rings. So the different joints within that now, here we call it a T, where you make a branch coming off of it. So you put the PEX pipe on, slide the copper ring into its correct position, and then you use the tool to tighten the copper ring down to give you a waterproof permanent seal. And we'll go through that one right in the shop. To join ABS pipe, use a type of solvent, cement. So here, they want to fit this ABS pipe into this connector. So you would rub the solvent on both sides, both here in the slot and on the outside of the pipe. And when you push it in, you get a couple seconds of time where you can twist and turn it, but after that it's going to set in place and then you're not moving it. So you have to dry fit things first. What I mean by dry fit, put the components together without any cement on them. Make sure everything works and is lined up correctly. Because once you put that cement on and set it in, you're not moving it after. So PEX is joined using mechanical fittings. The system uses a copper manifold at the point of entry. and a separate pipe for each water appliance. PEX pipe slips on over a nipple on the manifold, and that compression fitting secures it. Alright, so you look here, and this could look a little complicated. And I guess it is until you see what's going on. So here you have a main water supply coming in from the bottom here. If I just get my pen back here. So water's coming into the system this way, right here, up through this blue pipe. And then cold water can be branched off. It's like a distribution center. So it comes in here, and then water is branched off at different points. One of the places where we're going to branch it off is out to our hot water tank. So let me just turn that up. Okay, so here at the top, cold water is going out to your tank, and then so here cold water is leaving the system, going to your hot water heater, and then it's entering back in here, and then you distribute the hot water out. So every appliance gets its own water run. So you can come here to this this manifold is what it's called, and you can turn the water off to any section or any appliance in the house. So when you hear the word appliance, don't think it has to deal with electricity. So sink will be would be an appliance. Okay, a toilet would be as well. So toilet features and fittings. Now, I don't know how many of you have taken the top off your tank for your toilet. It's pretty smart the way these things are put together and how it fills the bowl. So we're all familiar with the idea, push down the handle. And I guess not a new concept, push the handle. And what happens when you push the handle down is that you're going to lift a valve here on the inside, a little flapper valve. So, it's usually closed. You push down the handle. It's connected to an arm and then a chain. So when you push down on it, too much zoom. Okay, so I got that fixed there. Sorry about that. So you push down on the handle. It lifts this seal and lets water go into the bowl. So your tank, as you know, holds water. So you push down the handle, it lifts up this valve. Water is then able to flush into the bowl and then takes away the waste. To refill it, you have a water supply line coming in, and it uses a type of float valve. So different designs for it. But as the water level rises, a float will rise up, and when it gets to a height, it'll shut off the valve. So it's pretty ingenious. It's no batteries included with this stuff, right? Like it's all mechanically set up to work very well. You also find with toilets, you have two anchor bolts, and they'll screw the tank to the toilet. And then you have a gasket. So a gasket, when you think about plumbing, is usually a piece of rubber or material that prevents water from leaking. So if you were to take the tank off your toilet, there's going to be a gasket here, usually a rubber seal, that prevents the water from leaking from the tank outside of the toilet. Because it's only porcelain, water's going to leak through and get past it, so you need something to stop it. And same here on the floor. You need a type of seal. So you can have a wax-free seal. Typically, though, what you have would be a wax ring that you put over the bottom of the toilet. So this is where the toilet's turned on the side here. And this is the flange we were speaking of. Here's a picture of it by itself. So the toilet sits on top of the flange. And then there's two bolts that come out the flange. And you hand tighten them. So you don't use a wrench because you can crack the porcelain. You would hand tighten this down. And it's going to prevent any gases from coming out through and water as you flush from leaking out over the floor. Don't put your wax seal on, and you'll see that as you flush the toilet, water's going to leak out over your floor. So here's the idea, just showing a different diagram. So as you flush the toilet, everything comes down through, and you see the shape here? It's called an elbow, and it goes at 90 degrees. So it goes straight down, and it turns at 90, so this is called a 90-degree elbow. As it comes down, it goes into your main drain stack. And again, the stack continues on up because it's going to vent and bring air in from the outside and take gases away. And to get water into that tank, here's a shut-off valve again. And we'd seen that in one of the other lessons there, the one before this, that you have a hose that brings water into the tank, and that's got its own valve.